Welcome to The Explainer. Today, we're unpacking a massive transition that's happening in tech right now. The shift from relying on single large language models to building fully orchestrated, multi-agent AI ecosystems. And we aren't just going to sit here and talk about the theory either, because our focus today is specifically on the steps to build. We're actually going to lay out a concrete, step-by-step framework so you can construct these systems yourself. Here is our blueprint for today. First, the agentic paradigm shift. Second, choosing your AI framework. Third, steps to build AI agents. Fourth, architecting multi-agent orchestration. And finally, enterprise integration at scale. We're moving step by step from the foundational concepts right into practical enterprise-grade construction. All right, part one, the agentic paradigm shift. To really understand how to build these systems, we need to quickly contextualize exactly where we are in the broader evolution of software architecture. So there's been this really consistent pattern of decomposition in software, right? In the 90s, we had these massive monoliths. Then we moved to service-oriented architecture, and by the 2010s, we were breaking things down into microservices. But here's the big difference. While microservices decomposed code for a better development lifecycle, the 2020s bring agentic AI. And agentic AI decomposes tasks and goals for autonomous execution. They're solving fundamentally different problems. Think about the old way of traditional software. It's rigid. It executes predefined, hard-coded logic with absolutely no deviation. Contrast that with the new way. While generative AI alone is just reactive, an AI agent actually uses a language model as its reasoning core. It uses it to perceive its environment, reason through a problem, and then act. So instead of following a strict script, the agent literally writes its own script at runtime to achieve a specific goal. It's wild. But keep this fundamental rule from our sources in mind. The architecture should follow the problem, not the trend. Actually, that's a great mantra. We aren't tearing down our existing microservices to just replace everything with AI. As a builder, your goal is to add a cognitive layer on top of your existing architecture.
Moving on to Section 2, choosing your AI framework. To construct these intelligent systems, you absolutely need the right foundational scaffolding. So let's evaluate two of the major multi-agent frameworks our sources highlight.
Comparing the frameworks, AutoGen is fantastic when your build requires automated coordination between agents, especially with strong human-in-the-loop controls. It lets you guide decisions without having to manually orchestrate every single interaction. LangGraph, on the other hand, is built for creating a sequence of steps, kind of like an adaptive map that the AI follows. It comes complete with deep memory, so the system actually remembers past actions and adapts as it goes.
But listen, whichever tool you choose, keep this in mind. The framework's absolute primary superpower is abstraction. By reducing the heavy lifting of multi-agent interactions, these frameworks ensure your development team isn't bogged down just building infrastructure. Instead, they get to focus entirely on writing the business logic, the policies, and the playbooks that actually guide the agents.
Okay, Section 3, Steps to Build AI Agents. Now we pivot to the core how-to blueprint. We're going to look at a proven, deliberate framework used in the insurance industry to move smoothly from an early pilot all the way to a robust production deployment.
Surviving the transition to production is tough, and it requires sequential milestones. While there are some intermediate design phases, our sources highlight three absolutely critical jump points. Stage 1 is aligning business risk, Stage 4 is executing through a specialized tooling layer, and Stage 5 is embedding the agents deeply into enterprise platforms. Let's break these down. So, Stage 1 is all about clarity and boundary setting. Before anyone writes a line of code, your team needs strict alignment on where AI agents should intervene and where they absolutely should not. In insurance, for example, builders combine LLMs connected to their own secure data, a process you probably know as RAG, or Retrieval Augmented Generation, with strict deterministic rules. This ensures you maintain total control over highly sensitive logic, like underwriting, while still getting that incredible flexibility of AI. Skipping ahead to the execution phase, we hit Stage 4, the tooling layer. This is where you equip your agents with the specific tools they need to actually interact with the world. For an insurance builder, this means giving agents access to natural language processing so they can read claims documents, computer vision for assessing vehicle damage, and anomaly detection for sniffing out fraud. And crucially, explainability tools are mandatory here. If an agent denies a claim, regulators and auditors need to know exactly why that decision was made. No black boxes allowed. Which brings us to Section 4, Architecting Multi-Agent Orchestration. So, you've got your business rules and your tooling layer.
How do we get all these various models, tools, and agents to actually collaborate seamlessly on complex workflows?
Applied AI research shows a pretty clear evolution in how we build these. We started with single agents, which are great for narrow tasks like basic customer support, but they just don't scale. Then came loosely coupled agents that operate in parallel but barely even interact. The real gold standard for enterprise building is the orchestrated multi-agent system. Here, specialized agents execute defined tasks under a unified coordination layer. That layer acts like a manager, determining the execution order, managing dependencies, and making sure everyone's outputs align.
But for that orchestration manager to actually work, the agents have to speak the exact same language. This orchestration relies heavily on standardized communication protocols. When you're building, you'll implement things like the Model Context Protocol, which standardizes how agents securely access external enterprise data and tools. Then, you use an agent-to-agent protocol, which governs how the agents negotiate, delegate tasks, and pass information to their peers. These protocols guarantee semantic consistency across the entire system.
Finally, Section 5, Enterprise Integration at Scale. This is the last crucial step of our building blueprint, where we actually plug this newly orchestrated intelligence into the real-world enterprise ecosystem.
As we established earlier, AI agents do not replace your core systems. They work through them. To build successfully at scale, your agents must be directly embedded into your existing infrastructure. This means tying your agentic orchestration layer straight into your policy administration systems, your CRM tools, and your massive data lakes.
By integrating deeply like this, these agents move far beyond simple task automation. Instead of just automating one single step of a process, they operate across entire workflows. Picture this. They can pull a customer record from a CRM, validate a document with computer vision, check the policy rules, and route an early assessment, all in one fluid motion. And the best part? They are programmed to tap a human worker on the shoulder only when the risk or complexity crosses a predefined threshold.
Ultimately, all the steps we've covered today are building towards an incredible future state. Our sources put it perfectly. Enterprises are moving toward dynamic ecosystems where agents can form, dissolve, and reorganize in response to tasks much like human teams. We are literally building environments where probabilistic reasoning seamlessly meets deterministic rules, creating autonomous teams of agents that just reorganize on the fly to solve problems.
Which leaves us with a pretty critical question for you to consider as a builder or a tech leader. As we shift from decomposing static code to decomposing complex autonomous goals, is your underlying architecture truly ready to support these dynamic ecosystems? Take a look at the frameworks and steps we discussed today and start laying that groundwork. Thanks so much for joining me on this explainer, and happy building.